Okay, our last example from 14.5. Here's example number 5. A company is increasing production of peanuts at a rate of 50 cases per day. All cases produced can be sold. The daily demand function is given by P equals, where Q is the number of units produced and P is the price in dollars. Find the rate of change of revenue with respect to time. So how is the revenue changing over time when the daily production is 20 units? So if I was off to the side writing my givens, what do we know? We know that we have, did I say 20 units? I meant 200 units if I said 20, sorry. We have 200 units. So I know that Q is 200. And it also said somewhere above, here it is, that the production is increasing at a rate of. So they're making more and more and more cases per day. So the quantity over time, can I call that dQ dt, is increasing, so positive 50 cases per day. Okay. And then I have this kind of P equation that they gave us here, price. And it's asking us to find what? Well, it looks like here it's asking us to find the rate of change of the revenue. So I want to figure out the rate and change of my revenue. Can I say dr dt, right? The revenue change. And so remember, the second thing that we have to do is figure out some sort of a formula. Some sort of a formula that relates all this stuff together. And if we're trying to find the rate at which the revenue is changing, we probably need a revenue equation. And if you remember, revenue is always Q times P, quantity times price. And so we have Q here, and we have P from up above that they gave us. And so now we have this revenue equation. Revenue is Q times P, and we can plug in our information. Now, I'm going to make that revenue equation look a little bit nicer by distributing the Q. And so I ended up getting 50Q minus 1Q squared over 200. So here is my new revenue equation, and I want to find the rate at which that revenue is changing over time. I want to find the derivative with respect to time. So find the derivative of revenue, dr dt. I ended up getting 50 dq dt minus, and I pulled this 1 over 200 out in front as a coefficient, and then I just found the derivative of q squared. That was a little bit easier for me than doing the quotient rule. I noticed that there was a 1 over 200, that's just a number that I can leave out in front, and then I can find the derivative of the rest of it. So the derivative of q squared with respect to time is 2q dq dt. All right, we've got a lot of variables. We're not really sure what dr dt is. That's what we're actually trying to find. Do we have a dq dt? Oh yeah, wasn't that the 50 cases per day? We do have a q. Wasn't that the 200? And so I should be able to plug in everything, and I should be able to figure out what dr dt is, the rate at which the revenue is changing. Using my calculator and plugging all my values in, I ended up getting 2,400. So let's talk about what it means. If we were doing a sentence, we could say, well, when we produce 200 cases, the revenue, because that's what dr is, the rate in which the revenue is changing, my revenue is increasing by a rate of, isn't revenue normally in money over time? And so it's $2,400 per day. When we produce 200 cases, my revenue is increasing by $2,400 per day at that moment. Not that I only have $2,400, but I'm getting $2,400 more per day as soon as I go to produce the next case of peanuts. Pretty cool, huh? All right, make sure that you practice all of those. That was the conclusion of chapter 14. Make sure that you work through the review so you can practice and get your extra credit. Please, please, please let me know if you have any questions. I'm here for you if you need anything. Like I said in the last video, I miss you guys.